So good afternoon, everyone. My name is Isadora Almeida, and today I'm going to present my master's thesis titled Digital Twin Interface for Facility Management using openBIM standards. And this work was done by the supervision of Miguel Azenha with the company D2A, represented by Diogo Drummond, and in collaboration with Andressa Oliveira. So a digital twin is a virtual replica of a physical asset connected to real-time sensor data, and this allows facility managers to monitor, analyze, and optimize building operations. D2A already implements these principles in facility management by using real-time data from sensors to manage building systems. D2A collects and interprets this data from sensors, and this can be accessed through 2D views and dashboards. And while these systems already operate as a digital twins, it lacks a 3D component. So the objective of my research is to integrate a BIM model to the D2A process and create a digital twin interface that allows to visualize dashboards and access equipment data by clicking on the equipment. Also visualize sensor data on the monitoring areas, and also track space occupancy. So in facility management, the BIM model evolves into an asset information model, focusing on the operational phase of the building. The AIM model centralizes essential data for maintenance and management. By using openBIM standards, we can ensure that the interoperability of the data across the platforms. However, the model itself contains only static data, meaning it doesn't update in real time without additional inputs. So to extend the model to digital twin, we integrate it to digital sensors that will lead to digital twins and allows to integrate to real-time monitoring and allows to a more intuitive visualization of the sensor data in buildings. So the digital twin platforms, they can be proprietary platforms or open solutions. They both allow for API integration, but the proprietary platforms, they have the customization predefined, and they are normally more expensive because you need to pay for the license. And the open solutions, they have more flexibility and customization because you can create as you need. But you need more specialized expertise and more considerable time to create the platform. So for the case study, we use the Randstad building, which is a building that D2A already does the data monitoring. It's a 3-level building divided by 3 zones. This building is primarily used for call centers, and we can see this division. In each zone we have a big workspace. Each workspace has around 90 workstations, and these divisions allows for a better monitoring and management of the spaces. So the current sensor monitoring that the D2A gives is done by 2 platforms. One of the platforms allows for a selection of the of the level, and then you can select a zone. By selecting a zone, you access an enlarged plan, and you can see the equipment and the result of the data. And by selecting the equipment, you received a more detailed data of each equipment. And also the energy valves, on the other hand, they are not displayed on the plans, but they are displayed on these 2D diagrams. In here you can see the 3 levels. And in the other platform, it displays the dashboards, where you can see more than one dashboard, more than one equipment, and also define an absolute time range. So the objectives and purpose of this work is the creation of an A model of the level 1 of the building, the creation of the web-based interface that allow visualization of the last 24-hour data, and the equipment that will be displayed will be FANCO units, hub sensors, and energy valves. And the filtering options will be temperature, relative humidity, PNV, and PPD, that are thermal measurements for thermal aspects, and occupancy. And also, we're going to have the dashboard integration. So the API is essential to connect the data from the sensors to the digital twin. And the D2A API allows for 4 types of interactions. The first one, we can achieve the hierarchies following this endpoint in blue. And then using this endpoint, we can receive a list of all the sensor codes as displayed in this second list. All the sensor codes, they have unique numbers and names, unique identifiers that will allow the connections from the API to the model. And then using the sensor code in this other interaction, we can receive all the variables that each sensor collects from the building. And then finally, we can create queries that defining the codes and the variables, we can receive the data. So the modeling, So the one of the main points of the modeling was the division of the spaces related to the monitored spaces based on the sensor locations. So in here we can see 3 spaces, and here we can see FANCO units and hub sensors, and we have these divisions. So we have these colors that they mean the monitored spaces for FANCO units and hub sensors. And we also have the energy valves, but they only measure flow rates, so they don't affect the spaces. And we also had the development of the level of information need that will be essential for creating the mapping. So the local D2A, this will be used for all the elements, which is the room name. The sublocal DTWA, they will be used for spaces and the people, which is the exact sensor code used on the API. And then the code DTWA that will be only used for the equipment. And that's also the exact sensor code from the API. And the occupancy DTWA, which will help to track the occupancy. And to check that all these elements had the required information, we did the IDS verification, and to follow the openBIM standards, we used ACA to create the requirements, and then Bonsai, that was Blender, to do the validation. So the interface was built by an existing interface created by Andressa for the Câmara Municipal de Matosinhos, that she used JavaScript, 3JS, and IFC.js. And then the objectives and purposes of the digital twin needed to create another functionalities. So the functionalities that we used from her interface were mainly the opening of the IFC. So from the objectives of the digital twin, we created the other functionalities that were the sensor visualization. So this is the final interface. I'm gonna show not all the sensor, but some. This is the temperature. In here we can see the legend that shows the colors, and here when you select some of the spaces, we can see the additional data. And here is the PPD, and where we need to select a season, which will change the data. And here's the occupancy filter, where we can see displayed in green and red if it's occupied or unoccupied. And here the dashboard visualization that is all the time available. And it also displayed the last 24 hours. And additionally, we have the equipment filter, where you can select a sensor, and the additional data will be displayed in here. So conclusions, when we were on the last weeks, we had a meeting with the Randstad facility manager, and he thought it was really good to have this interface, because it was better to see the data on the spaces with colors. It was better to see if they had spaces with problems. And he also suggested to have a connection with a management platform. And we also suggested to export a PDF report of the sensor data. But those things, like, do it to the time, we didn't have time to finish. And the future work would be to model the other levels of the buildings and also the other sensors available, following the requirements and standards defined. And also to integrate more time ranges, when you can select not only 24 hours, but like, I want to see, I don't know, like the exact same time or 15 minutes, whatever. And also to select the dashboards to the interaction. So if I select equipment, my dashboard will be will be related to my action, so to the equipment that I'm selecting. And also this approach demonstrates that using openBIM standards is very good to create a digital twin interface, so you can create interface really related to your goal. So that's it.